Welcome to Algebra 2, Unit 5, Lesson 7, Graphs of Square Root Functions. This is the last lesson that we're going to have in Unit 5, at least this year, and it is going to be a mix of new material with quite a bit of review material as well, because we have studied families of functions at length this year. So a lot of what we're about to cover is going to be review. Hopefully we'll be able to move through it fairly quickly, and there are some new twists in the road for square root functions. So I wanted to start off with a little bit of reasoning, just to put some context around what we're about to look at. So we know that the square root, and I put the x in there mostly because the next thing I'm about to write is going to be hard to write if you don't have like an x in it. So we know that the square root of x is related to x squared. You can get that there, is related to x squared, since these operations undo each other. So we know that if we have x and we square it, and then we square root it, we'll have x. We also know that if we have x and we square root it, and then we square it, we will be back to x. So the position of that exponent can be in or outside of the radical, and we know that the square root and the squaring undo each other. Okay, that we know. We know that those two operations are related. Therefore, and I am going to call your attention to this symbol right there, that symbol means therefore. That is not a made-up symbol, okay? That is literally what it means. You can find it in like the math programs. You might see it in a geometry textbook, okay? So 3 little dots looking like a triangle there means therefore. Therefore, the square root graph must be related to the x squared graph. If square rooting and squaring are related operations, then their graphs must be related. Now, we don't know how, but we figured they have to be related to each other. That is, it must be related to a parabola somehow. Okay, because we know that the graph of y equals x squared is a parabola. So when I go to graph y equals the square root of x, I got to get something that's related to a parabola, right? So because what's life without a little mystery? But how will the graphs be related? We just know that it's reasonable for us to expect that they will be related. But how they are related remains to be seen. So the parent function for our square root graph. So if you recall, the parent function is the simplest function in a family. It's going to have all of the characteristics of that family, but it's the simplest one. So the simplest function in the square root family is simply this: y equals the square root of x. Or you might have f of x is equal to the square root of x. And I kind of go back and forth in this lesson using y's and f of x's. And what I did on the notes handout does not necessarily always match what I'm doing in the PowerPoint, and that should be fine. Okay, there's actually one spot where I changed it in the PowerPoint because, well, you'll see when you look at the handout. But all right, so that's the parent function. That's like our base function. And now we want to take a look at the parent graph. But I won't look at it up. I do not know what happened. I have no idea how that's going to show up in the video. Okay, so let's go ahead and get that graphed. And you can use y equals the square root of x. Okay, and it looks something like this. You can also, in Desmos, if you don't usually do it, you can also use an f of x, and that's fine as well. All right, so what you can see there, and you should on your handout copy this down. You've got a little coordinate plane on your handout. If you don't have a handout, then if you're just doing this from home, you would write this down in your notebook as you're watching the video. And things to point out about this, it starts here at the origin. I don't know why I'm seeing two little laser pointers. I don't know what you guys are seeing. At the origin, and then it goes up steeply, and then it looks like it's starting to level off. And just in case the other laser pointer is the one that you're seeing, it starts here at the origin and it goes up steeply, and then it looks like it levels off. Now, it doesn't actually level off, but it looks like it's becoming less steep. So we're looking at a graph that has an endpoint and then goes off in one direction. Now, here's the connection between that and a parabola. The square root graph is the top half of a sideways parabola. So the bottom of the parabola would be down there. But if we included the bottom of the parabola, then it wouldn't be a function because it wouldn't pass the vertical line test. So, and this ties back to, if you remember several classes ago, I expressed my personal annoyance at the fact that if you had something like x squared equals 25, you got the plus and the minus. But if you had x equals the square root of 25, then you would only get the positive. This is related to the same, connected to why the graphs work the way they do. This is why a parabola has two sides, and the square root function only has the top part. It only has the positive part. Okay, it doesn't have the negative part. All right, so that's the parent function. So we're going to do an exploration here. We've covered transformations at length this year. So the exploration is intended to be a review, and we'll also introduce a few new ways that we can see transformations. And just to make sure that you're clear on what the directions are for this, we will do the first few together. So go ahead and get the graphing calculator up and running. And what I'm going to do here is put the parent function in, and we're going to use the parent function for a comparison, okay? And then below it, we will do the first graph. And what you should see is that it's the same shape graph, and it is moved left 1, 2, 3, 4, 5, so that the endpoint is down here at a -5. And so on your paper, you would write down left 5. Okay? Now, the next one is also y equals the square root of x plus 5, except on this one, the plus 5 is I did them out of order. Okay. You're like probably hollering at home, Miss Taylor, you didn't type it in right. I didn't hear you. Okay, this one was the left 5. And then this one where it is outside, we can now see it goes up. Up 1, 2, 3, 4, 5. Okay, up 5. Okay, so I'm going to pause there because if you wrote that down wrong, you probably need a moment to fix it, because I just go typing. Okay, so outside made it go up 5, inside made it go left 5. Now the third one has subtracting the 5, and it's got both of them, okay? And we've done enough of this so that you can probably figure out what it's going to do. I'm going to get rid of that little mark right there. Okay, assuming that I can type it correctly. So we have a -5 under, and then another -5 not under. And when we take a look at where that puts it, it has gone to the right 1, 2, 3, 4, 5, and also down 5. And so what we're focusing on is that end point. Okay, so right 5, down 5, same shape. Okay, that one goes right 5, down 5. So right 5, comma, down 5. All right, so that's what the activity is. Now, hopefully this doesn't shock you. It's not absolute earth-shattering, but you might have a couple things that you're like, oh, yeah, that's right. I forgot that the left and the right are backwards, or I forgot what the inside-outside number were, but hopefully you do remember doing it. So complete the rest of the problems on your own. For those of you that are watching the video from home and are not in class, you obviously don't have the handout, so you would need to know what the rest of the problems are. Okay, pause the video, go ahead and hop onto Desmos and make sure that you are completing all of these. And then what I would do in class is I'm going to circulate around, and I'll only go over things if they seem to be an issue. So if I start getting the same question from multiple places in the room. All right, so pause the video and see what you can do with it. Okay, now a couple of things I want to make sure that I address for those of you that are watching the video without the benefit of being in class. The way you would express the function of that particular 2 is you would say a vertical stretch. So on yours, if you described the role of the 2, but you wrote it as it gets higher or it gets bigger, what I want you to do is in your notebooks, change up colors if you can, or put a little asterisk next to something and just indicate that that's a vertical stretch. Okay. Now on the next 2, we are dealing with negatives, but we're dealing with negatives in different positions. So we're dealing with a negative out in front versus a negative inside the radical with the x. Now, if all you wrote was flip or reflect, that is not specific enough, because you probably noticed that they did not flip the function the same way. So for number 5, you do need to specify that that's a flip over the x-axis, and that number 6 is a flip over the y-axis. If you wrote like up, down flip or left, right flip, go ahead. It's not necessarily that that's wrong, but I do want you to make sure that you get in your notes the right verbiage for describing that. And then we end up with things that come in combination. So like the last one that I did had 2, it had like the right 5 and the down 5. You can have multiple transformations happening. So for example, this last one would be a flip over the x-axis. It would be a vertical stretch. It would go right 1 and up 5. Okay, so now if you've got other questions, so if you're doing this from home and you think you have it, but you've got a question about, say, number 8, number 7, something about it, and you'd like to ask me, you guys know how to reach me, okay? And I will be more than happy to go over any of these with you if you're not confident that you've got it down how the different transformations work. But I think those are the main things that are probably going to come up, is how to write the different kinds of transformations. Beyond that, it's just a matter of doing them enough so that you're able to remember them. Because it's not hard to know that something flips, but what can trip you up is not remembering which negative, like in which position, does what. And that's only solvable by handling the content and studying it. All right. Okay, so in this one, I want you to use your activity to make some predictions. So we're just going to change the order of this a little bit, where instead of graphing it on Desmos and then writing down the transformations, I want you to look at the functions and then make a prediction based on the function without looking at the graph, what you think it is going to do, and then go to Desmos and see if your prediction is right. Because ultimately, we don't want to have to go to Desmos every single time for all of these problems. So take a moment, pause the video if you're doing this from home, and make your predictions, check it on Desmos, and then indicate if you are correct or not. Okay, so I'm going to make some predictions, I guess. On this first one, I'm going to say this one flips over the y-axis, and I think it goes up 3. And on this one, I think it's going to go right 3 and up 3. Okay, your predictions should look something like that. Okay, if your predictions are an equation, if your predictions say stuff like up and down, okay, then you didn't answer the question right. Now let's come over here, and I am going to put in that parent function because it's easier for us to see how the function is transformed when we can see where it started. So this will be the square root of x. Okay, and I'm looking at that, and I can see that it is flipped over the y, so it's oriented the other direction, and it seems to have gone up 3. That looks right. I have to hover over the point there. And I have no way of going back. So I'm going to go check it on Desmos here. So thankfully, you guys have the, okay, on my notes here, I have a different number than I think I put in the PowerPoint, which isn't a huge deal because if you remember, like, the concept here is to get the transformations. So there's our, I probably wouldn't have even noticed that if I hadn't clicked the wrong slide. Okay, and I think the one in the PowerPoint was x minus 3 and then a plus 3. And so I can see that it goes right 3 and then up 3. The one on the handout is a 2, which doesn't change anything super significantly. It goes right 2 and up 3. Okay, it doesn't change the material being presented at all. Okay, we were just trying to get the transformations before we did the graph, so we should be okay. All right, now next one is what about transformations from one function onto another? So instead of transforming them from the parent function, what if we started at one function and we're going to another function, neither of which are the parent? So this is one where I know I made a change in the outline to the PowerPoint because the outline has like y1 and y2. And when I did this for the PowerPoint, I did it as f of x and g of x. Okay. And that was to avoid duplicating that y over and over and over again. So suppose we start at f of x equals the square root of negative x minus 3. So you kind of have to picture like, okay, what is happening there? It's flipped over the y-axis and then down 3. What transformations would it take to get to the square root of x plus 3 and minus 4? I'm so mad. Like, I can't touch my screen. Okay, well, I'm going to do it over here. You guys can rewind the video if you want and look at it. Okay, so the way I would maybe think about this is I'd be like, well, it is being flipped over the y-axis and I don't want it flipped over the y-axis, so I'm going to have to flip it back over the y-axis. And then it looks like I need to make it go left 3 from wherever it was. And then I'm going from a minus 3 to a minus 4, so I've got to go down 1. So if I had to make that prediction, I would say I've got to flip it over the y-axis, I have to go left 3, and I have to go down 1. So what I'm going to do is graph it. And I'm going to graph that starting one. Okay, and it's like masked a little bit by this here. Okay, so I can see that it's flipped over the y-axis and it is down 3. Now that's the graph that we're going to start with. I want to get it to this one. X plus 3 minus 4. Okay. Now, to figure this out, I was going in this direction, and in order to get the blue one to go in the blue direction, I had to flip it over the y-axis. Okay, so it was going this way. Now I need to get it going this way. So flip over the y-axis. From here, I did go left 3. And if I look at that endpoint, I did go down 1. All right, so these can be tricky. I would recommend graphing both of them and checking any kind of answer you come up with. Yeah, but with the graph. Okay, so hopefully I can manage doing this without inadvertently going forward a slide. All right, so there's one really tricky piece with this. Combining a flip over the y-axis with a horizontal shift can be hard to see, and it's going to do something that you don't expect to see. And you might have noticed that I did not combine any of those. So if you want to scan back over your notes for this, that every time we had the negative under the square root, I just left it as an x. I did not try to flip it that way and also shift it. So the deal is with that is your first guess is probably going to be this. It's probably going to be flip over the y and left 3. That is your first guess. I want you to notice what happens when we graph it, though. Okay, so here is our original, and here is our new one. Okay, flip it over the y, we're good. And it made it go to the right instead of the left. And you think, everything has come undone. Miss Taylor, you have lied to us all year. Math is not consistent because over and over and over again, like the adding the 3 underneath or on the inside made it go to the left. And I do want you to notice something, because when something like this happens, we want to be curious, right? So watch what happens when I delete that negative. Okay, notice that now it is a shift to the left. So just the x plus 3 shifts it left. When I put the negative in, it flips it, and it's like it flipped it from the shifted position. If you think about it that way, like it shifted it that far over and then mirrored it over so that it actually ended up over on the other side. Okay, so what I want you to see with this is kind of the reasoning. It's almost like an order of operations deal. Okay, I'm terrified I'm going to have the wrong thing up, and no, okay. What we actually have to do is we have to factor like a -1 out from that radicand. So if you have a negative x and you factor the negative out, you'd be left with a positive x. But if you had a positive 3 and you factor out a -1, you would be left with a -3. And then, of course, you don't need to put the 1. Okay. And what we've got there is basically, if to put it in terms of stuff you've seen before, it's an order of operations. So now you can see it where it's a flip over the y-axis, and then you can see, oh, that's right, it is a right instead of a left. And what it means is that you do the shift first because you do parentheses first. So you do slide it to the right, to the right, and then flip it over. Slide it to the right and then flip it over. And so, not sliding it to the left. I think I said that backwards. This is not my finest video. This is not my finest video. Now, here's the good news with this. I typically do not give these to my Algebra 2 students because they are tricky and because they're this weird little thing that looks like the math isn't consistent. The math is still consistent, but it kind of looks like the math is not being consistent because of the order that you're doing those transformations in. But I wouldn't really be doing this lesson well if I didn't address that. Okay. So don't lose sleep over it, and you will have access to Desmos for anything where you might feel a little shaky on that. Okay, last topic is domain and range. And we haven't touched a whole lot of domain and range this year. We've touched it a little bit. I said the domain of every single quadratic on the planet is all real numbers. Okay, and we don't want to forget that. This is a good unit to bring back that domain and range. So the overall method, and I'm going to teach this the way that I do it. Okay, we're going to do it with the graph. And the overall method that the way I teach this is find the endpoint, okay? Because the endpoint is going to show you where the function cuts off, okay? So there's no more x's and no more y's after you get to the endpoint. That's it. Then note which direction the function goes. Is it going up? Then your y's are going to be greater than. If it's going right, then your x's are going to be greater than. If it's going down, y's are less than. If it's going left, x's are less than. If it's going up and to the left, the y's are greater than and the x's are less than. So just you want to find that endpoint and then pay attention to which direction the function is going. Recall that domain is all possible x coordinates. And your range is all possible y coordinates. Okay, so we don't want to forget our definitions there. If you get them backwards, you will get all the answers wrong. And you can probably be pretty safe in assuming that somebody writing a multiple choice test is going to distract you with switching them. So here are a couple of examples. Hopefully I can do these again without messing up. without messing this up. So I'm going to click on the Desmos calculator. And I'm going to go in and type in my first function here. Okay, and I'm going to go ahead and like it's not letting me put a dot at the endpoint, but there it is. I'll hover over it so you can see it. It is 3, 2, okay? And you can see that on the actual graph. I'll go ahead and, okay, 3, 2. So my x is 3 and my y is 2. Now notice which direction it goes, okay? So domain, and we're going to label that with the D. Okay, domain is the x's. Notice that it's going to the right from the endpoint. So I'm going to say x is greater than or equal to 3. Why is it greater than or equal to? Because it's going to the right. Now you could also say that as it starts at 3 and is going to go to infinity. And you do need to use the bracket there, not the parenthesis, because the 3 is included. Okay, the 3 actually is a point on that square root function. And then our range is the y's, and notice that the graph is going down from that endpoint. And so we would say y is less than or equal to 2. Or you could say it starts at negative infinity and goes to the 2. Now, I'm actually more comfortable doing this with inequality notation for these kinds of functions, just because the less than, greater than works for me. You might be more comfortable with the interval notation. Just make sure that you use a bracket and that you get your expressions in the right order. So if you wrote this 2 to negative infinity, that is incorrect, because the lesser one always has to come first. So you would need to make sure that you switched it. Also be careful, that did not really look like a good bracket. Okay, so there's our first one. It's got to be so careful with my mouse and the screen. All right, second one is x plus 4, no, negative. Okay. Oh, this one does give me the option of clicking on that endpoint, probably because it is the x-intercept as well. So this one, we'll notice that we have an x value. I almost touched my screen to change that tool over, and I cannot do that. Okay. Do I have my pen? I do. Okay, so we have x is the negative 4 and y is the 0. I'm just going to note which direction it goes. So once again, it's going to the right. So if it's going to the right, that's where x is greater, to the right. And so we would have x is greater than or equal to negative 4. In interval notation, that would mean you're starting at the negative 4 and you're going to go up to infinity. For the range, this time the y is also going up. Okay, the graph is going up from the endpoint. And so we would say y is greater than or equal to 0, or it starts at 0 and goes to infinity. That's where you'd find those bigger numbers. All right, so that's how I would recommend doing this. You can also do this if you know the transformations and you can sketch a quick graph. You don't necessarily have to do the graph on Desmos. You could do a quick sketch of one, especially if it were, say, the SAT part, where if you don't have a graphing calculator, okay, you might have to do it out by hand, and you should have the ability to do it out by hand. So I think this is the last slide. So this is a couple of practice problems. I will go over these in the video, not like the other ones where I said, I'm not going to go over them in the video. I will go over these ones because I think these might be a little bit shakier for you. So pause the video, come up with your own answer first, and then unpause the video to check check your reasoning and your answer, and you can make some corrections if you need to. All right, let's get that first one on there. Okay, so looking at this first one, my x's this time are going to the left, okay, because of the flip I have on there. So my x's going to the left would be x is less than or equal to, and it looks like my x coordinate there is a 0. Okay, so x is less than or equal to 0. Or you could have said negative infinity and stopping at the 0 would have also worked. And then range, the y's are going up because it's going up. So that would be y is greater than or equal to 5. Or your interval notation would be starting at the 5 and going to infinity. All right. Let's go change this one. So this becomes a -3. And we're going to put in another negative here, which bumped it off of my viewing window. There it is. Okay. And for this one, we have the domain is the x's, and this time x's are going to the left again. That's because we still have that flip over the y-axis. This is my x and this is my y, so x is less than or equal to 0. Or you could say negative infinity to 0. Make sure you have that bracket. Does matter. In fact, a distractor choice would be to put a parenthesis around it instead of a bracket. So definitely want to know the difference there. This time my y's are also heading down. So y is less than or equal to, and in this case it's -3. Or you could say negative infinity to -3. All right, so hopefully that gave you some practice. I do not have a preference on which notation you use. Probably on your in-class test, which at the time I'm recording this is way far away. I'm recording this very much in advance. But I probably on the in-class test, I will accept either form. On the at-home test, I might request like both forms, just again to kind of circumvent the using of the photomath and stuff to make sure that you understand the concept. And of course, you'll have access to this video and you'll have access to the notes when you're doing your at-home test. All right, I believe that is the last slide. That is the whole lesson. I'm going to throw out an apology for one, copying the problem wrong. Like I had a problem copied wrong. I'll try to fix that before we do this in class. And also, the 2 times that I accidentally touched my screen. I can go back and re-record those slides, but depending on how far into the problem we are, and it also makes me have to stop the video multiple times from that point onward, which is aggravating. So I apologize for that. Yeah, but anyway, you guys know how to reach me if you need me, and I hope you have it's weekend here. But you have a wonderful weekend whenever you get a weekend.